In today's workshop, we're going to be looking at plane detection, surfaces that are horizontal and vertical. And once we've got those surfaces detected, we'll be overlaying an image on top. So let's get started. We just had some people join, so let me just run this real quick so we can look at it. This app is going to identify horizontal surfaces, and then we're going to, I'll just rerun it right here. Welcome to the new people that just joined. What I'm going to do is find a surface and replace it with grass. And actually I have a glass desk, which is really impressive because my desk is actually glass, the surface right here. And it's replacing the glass with grass. No,
Nice.
Bad humor there. Okay, so that's it right there. I'm going to close what I did right here. And like I said, the code's available online. I'm going to close this project and we're going to start a new project right from scratch. So let's go ahead and open up. We're going to create a new project. And I'm going to set this up from scratch. This is the shortcut, by the way. Is to go ahead and pick an AR app, an augmented reality app, and what Xcode will do is it'll set up everything for you. I'm going to do it from scratch only because this helps us understand what Xcode is doing.
Yeah, this might give me a hint as to what's going on with mine.
Yeah, great. So I'm setting a single view app, and I'm going to call it hello grass or something, and hello horizontal replacement or whatever. And we're doing Swift, and our user interface is going to be Storyboard, and then click next. And I'm not going to do a Git repository because I don't really need to for this. This is going to be just a throwaway project. And then the next thing, once we have this, I'm going to take the landscape left and landscape right out of the device orientation, only because it seems to confuse things, and also it slows things down quite a bit. So I'm removing these two for now. And once that's done, we go into the storyboard, and I'm going to go ahead and add the necessary scene view component right here. So this is our view controller scene. I'm selecting that, and I'm going to go right up here, say add, and it's going to be called an ARSC scene kit view. So we're going to take that. Let me move this here. I'm going to drop this right in the middle, and I'm going to just resize it to take up the whole screen, the whole device rather. The whole device screen. So I've done that. So this is the scene ARSCN view, the augmented reality scene view. I pin this to I'm going to pin this so that we have this set up to go full size, right? So constraints are going to be 0 all around at 4 constraints. And that's it. And so now it'll look good. I'm going to move this out of the way right here to give us some more room. And I'm going to put this here so everybody can see it too. I'm going to do next is add, oh, this is annoying. I want to get this out of the way. Okay, at least you're not seeing it. That's good. What I want to do is I want to go to my assistant view, click that, so that way we can see the code, and make this a little smaller here. Okay, whoops. I didn't mean to move that, so I'm going to do move, and I'm going to now just make a connection into the code so that I'll have my outlet connected. So I'm just, if you're new to Xcode, this is a control drag operation where I'm dragging this from the view storyboard into the view controller itself. And I'm going to say, what did I call it in the, let me use the same terminology here that I used. Let's see, what did I call it in the code? Well, I'll just call it scene view, probably the same thing I used when I did the example. So I'm going to make the connection, make sure that it's an outlet, and storage is always by default weak. Make the connection, and so there we are. Then that's it. So be sure to import ARKit in here, and that warning will go away. And now we should have that go away right here, where we now are able to make the connection, and Xcode recognizes it. So that's it. Those are the first most important things that need to be done to get this where you are able to have the ARKit working. So let's go ahead and go for, I'm going to do now is I'm just going to copy so you guys don't have to go through the pain of me typing and watching me type. I'm just going to copy the same code that we've been using since we started this. The first thing we do is, well, I add a delegate. Okay, so the delegate is going to let us do the updating dynamically. So make sure you add that delegate in there. And then what we do is we make the we have the configuration as we did before. We want world tracking configuration. So I'm just going to copy that. And then in the view.load, we're going to go ahead. In fact, I'll just copy everything right here because I think you're all familiar with all of this so far, right? We're setting it up an AR world tracking configuration. So we're going to set that up in here. And then in view.load, in fact, let me get rid now. I don't need the, I don't need to see the assistant editor anymore. I just want the code. So let me take this out. And we're going to go right back to just the code so you can see the screen. All right. And if anybody has any questions or is having trouble seeing something, please just go ahead and jump in and let me know. And I'll slow down or fix whatever the problem is. All right, so now let's go ahead and, ooh, that's weird. My keyboard's got stuck there. Let's go ahead and bring in what we need in the view controller. And that's basically, we're gonna set up the delegate and we're gonna bring in, let's see, I'll bring everything for now. And, okay, so what we did is we're bringing in the delegate self, and then we set up the debug options like we've been doing since the beginning. We want to show the world origin. This is an array, as you can see. And then the other debug option is we want to show the feature points for this in the system. So show feature points, which is what iOS is using to track different surfaces. And then we're going to tell it what type of plane detection we want to be using. And that's part of, again, the configuration that we declared up here earlier with world tracking. We're telling it that we want a plane detection horizontal. And then we run the session. So we don't, last error right here, we don't have this yet. So I'm going to get rid of this because we don't have the create turf or create grass or whatever. We're not doing that yet. We're going to go through that in a second. So this gets us set up right now. If I were to run it, I think we would just, well, we would just be seeing, let's go ahead and give it a shot. See what happens if we run this as is. I'm going to run it. And we should just get we should just be seeing the debug options if everything worked out okay. Okay. Run session configure. Oh, what did I get? Oh, of course. This is the thing that we forgot. I didn't even look at the error because I think I know what I forgot to do. In the plist, Apple forces us to request permission to use the camera, and if we don't, it's just going to crash. So we have to go into the plist, info.plist, and add a key in here that's going to request privacy. So what I do is I hit plus on the info plist property list right here, and I'm going to go and say hello. What's going on? It's not letting me click it. That's the right one, assets.
It's not required device capabilities.
Yeah, sorry, I'm being derpy. I have to hit enter. So what I want to do is I want to look for privacy, but it didn't. Oops. There we go. I'm not sure what is going on there. Privacy, camera usage description. So just start typing privacy and that will come up in there. And then in the string, you give it the text that the string that the user is going to see when it requests the camera access. So in this case, I'm going to say, camera needed for AR or something like that. It doesn't matter. Get rid of that one. So let's see if that does it. I think that did it. And if it was another error, then I'll find out real quick. Okay. So horizontal replacement would like to access the camera needed for AR. Hit click OK. And now what I have is I have my, let me show you in the code right here. We have in the view controller, what you're looking at here with the blue, green, and red, that's the show world origin element, so in the debug options. So this was the origin where I was holding my phone. If I go my device, if I go right here, this is literally when it disappears, is right where it was when I launched the app, and it's going to maintain that spot. No matter where I go, this is my X, Y, and Z axes. Then the feature points, that is, as I move around, see the little yellow orange dots? So those are the feature points that iOS is using to identify different objects on there. So it's even doing it on the keyboard. You can see all over right there. All right. Any questions so far? Cool. Okay. So what I'm going to do now is we have the feature points. The next thing we want to do is we want to start identifying planes and looking at I'm going to add some delegates next. So they get fired anytime Xcode is finding a surface or plane. So let's go ahead and grab that. Here's the delegate. So the first one, let's copy this delegate in here. And we can go right here. Okay, so this delegate is, and by the way, if you don't recall this, what you have to do is this delegate is called did add. And you can simply type function did add, and it's going to pull up the renderers. So you'll notice that here's did update and all this stuff. So the renderer did add is, where is it? Oops. Render. it'll come up when you type in function did add, and it'll just come up with you want the renderer. And everything is stock right here. What I'm doing is I added a way to extract the plane. Otherwise, just if it doesn't find it, that's because the guard statement, it's going to just return back. And no matter what happens, and and if it doesn't return, then it prints new surface detected. So every time it detects a surface, we're gonna get a print statement in the console here. So let me make sure I can see that. And yeah, okay, so I'm gonna run it, and let's take a look what happens now when we detect a surface. Okay, so there we go. We detected a surface. You notice the console statement says new surface detected there. And the desk is one surface, so it's only finding, it's only saying new surface detected. If I go over to the floor, it's going to identify more surfaces down there. So you notice now we have 3 new surface detected statements. So that's working. So this renderer gets triggered anytime we detect a new surface. So all right, I'm going to add the next renderer, which is doing the same thing. This renderer is going to be fired every time we have an update. So renderer. And it's called did update for node. So I'm going to go ahead and add that in there. And we can copy the same stuff that we have up here and add that in here instead. So new surface updated. All right, so this one gets, so what happens is, as I move my device over my desk or whatever the surface is, ARKit is learning, the surface is bigger than we thought. It goes to here, right? As I move to the left and that. So it's going to trigger new surface updated, or I'm just going to say surface updated, because we don't know if it's a new surface or not. I'm going to go ahead and run it. And let's go take a look at that. Okay. So I'm going to look down. It should find it. And there we go. So it's triggering new surface updated a lot, like thousands of times, because see how often we have that. Yeah, see, it's constantly updating. See how many we have here? So we got new surface detected, and then we got, dozens of surface updated statements. So we're going to use this. We're going to use these two to determine where the surface is, and then apply. What we're going to do is we're going to apply a texture to that surface. Just like we did last time, we were applying textures on the spheres and different shapes, like the Earth when we had the solar system, we were applying textures to those. In this case, we're going to apply the textures to the surface that we detected. And the render gives us everything that we need. It gives us this AR plane anchor. And so plane anchor is defined here as it has all of the components that we need. It has the X, Y, and Z of the plane. It also has the let's see. Well, it's got a 3D basically. It's got the 3D including the dimensions, so it can position. It knows exactly where the plane is in space. So what I do now is I go and I grab Oh, there's one more renderer that we need. And we're gonna need to remove a shape or node. And the reason you do that is because the system's gonna figure out that it made a mistake, right? So a lot of the times it thinks it's got a plane somewhere, but it's not really. As you move over, ARKit is gonna say, oh, you know what, this is not really part of this plane. And so we need to be able to remove nodes. So I'm gonna add that in here. And so did remove node for anchor. And so when this gets fired, it means that it found a mistake and it's fixing it. So let's see if that works. Let's go and run that. Okay. All right. Service updated. It's not making any, still updating. No mistakes. Oh, I just saw it. I think I just saw one trigger earlier there. Let's see. Yep. Oh no, that's new surface detected when I went on the ground. Well, it looks like it's not making any mistakes. I'm almost positive last time on testing, I saw the did remove node get fired. So hopefully we'll get that. We'll see that later on. Okay. So here's the function. We're gonna add a function to create that returns a node right here. And let me just copy that over into Xcode and we'll go over it. And I'm gonna add that in here. So this creates the landscape. And by the way, it doesn't have to be grass. It could be anything, right? So create turf doesn't have to be create turf. It could be, you know, whatever you want to play with. I thought grass would be kind of cool to have that, but it can be anything you want. What's going to happen here is we're going to create a node as a plane with a width and height of one. This is going to get changed as the renderers are fired. So this is just, you know, arbitrarily 1 meter wide and 1 meter high. That's what this does right here. Then we apply the material using the UI image of grass, and this is something we're going to go pick, and I'm going to do that in just a moment. Then we give it the position, and in this case, we want it to be in front of us by a meter. So we're going to say, we're going to make this a vector, a 3D vector, positioned x0, y0, z-axis, 1 meter in front of the device. Actually, 1 meter behind the device, because remember, the device always faces me, right? I'm looking at the screen. So it's a -1. Use extension to rotate. Because it's flat, what we do then is we're using the Euler angles to rotate it 90 degrees, because otherwise it's going to be just, well, you know what, let's do this so you'll see what I'm talking about right here. I'm going to take this out right now and let's run it. Oh wait, let's go ahead and add this. I'm going to grab the code here for part 2. And we're going to do add node like this, right? Okay. So this gets us, did add, new surface detected. Oops, not twice. Oh, I probably should bring my extension in as well. I made a little extension that we're going to use in just a moment. So before I forget, this is going to be our degrees to radians. I'm going to add that to the code. because we're gonna move it in just a moment. So first, I'm gonna set it up without that flip. Basically, is what we're doing. Is we're flipping the image. Okay. Oh, I see what I did. We're not passing it this yet, so let's just take this out for now. And I think that's it. Okay, so we should be able to run it. At this point in time, what's going to happen is, because we're not telling it where to put it, it's just going to create a node and it's going to be just in front of us. So let me bring in an image and then I'll run this. I'll just run it in a second so you can get an idea of what we're doing. To bring an image, all you have to do is go and I wish this would stop doing that. Okay, let's go find an image. How about, what's a good surface? Any special requests on the surface you guys want to view other than grass? Okay.
Wood?
Wood? Yeah, all right. All right, let's make it wood. This looks okay right here.
Yeah.
All right. And wood.jpg.
Does this need to be a tileable image, Chris?
No, it's gonna, let's see what happens. Yeah, that's a great question. I think, it seems to me like it just stretches it.
Okay.
Automatically, yeah. So having a bigger image may be good, but it's either tiling it. I couldn't tell, actually. I couldn't tell if it was tiling it or stretching it. One way to find out is we can get something with a border around it, I guess.
Well, actually, this will we can probably tell with this because it's got enough of a pattern.
Yeah, right. Yeah, exactly. Okay, yeah. All right, so let's go back to Xcode. And what did I do with the, what did I do with my image right here? I'm gonna make sure I bring it into my assets. So what I do is I'm just gonna create a new image set and we're just gonna call it wood. Like so. And then I'm gonna drag into that the image I just downloaded, assuming it's in my downloads or desktop probably. Nope, it's gotta be downloads. Well, it's, oh, there it is. Okay. All right, let's drop that here. It doesn't, oh, it's got some, you notice it's not a transparent background, but that's all right. We'll work around it. I mean, it'll be fine. I'm not gonna mess with it right now. So I'm gonna do is I'm gonna change the name to wood and let's see what happens here. So as I run this, let's take a look at what we have so far. So we've got the origin and we're looking for horizontal plane detection. Here's what creates the node and it's positioning it. We're not rotating it yet. So it should return the node to create when we call this function right here. And hopefully it's being called here, right? Okay, create turf and add as a child node to the root node. And that should do it, right? Let's find out.
And does this get called on On the detection of the plane or on the update of the plane or both?
Right now, only on did add.
Okay.
You'll notice my did update right here. They don't have anything. So yeah. So right now, all we're doing is as soon as it detects a surface, you go ahead and look down here. Okay, so it saw something and then it got updated. And it added, did it add it somewhere? Where is my?
Yeah, there it is.
There
There
it
it
is.
was.
Okay.
Right.
So it's going to keep adding. Now notice this, every time it detects a new surface, it's going to add it, I think. And in this case, it added it a meter ahead of us. And it's got those black borders, like, you know, that's okay. This will be interesting. So there it is. It's just throwing it. And you can see where it's throwing it. It seems to be, if I hold the device where I'm along the Z axis, it's interestingly adding it. It looks like it's offset a little bit, which is kind of puzzling because I would expect it to be centered along this axis right here. But there it is. Okay. So what I want to do now is I want to go ahead and flip it. And the way we did that, and remember, did I comment that out or did I just delete it right here?
I think you just commented it out.
Yeah, cool. So what we want to do is we want to take the node and apply a Euler angle transformation to it to rotate it along the x-axis. So the x-axis is going to flip it like this, right? It's going to go like this and it's going to go like that. So that's, you know, when we do that along the x-axis, 90 degrees, and this is using that little extension that we have down here, degrees to radian, which returns basically self pi divided by 180. And that's how we do the conversion right here. So let's run it again and let's see what that looks like. Okay. Okay, so now I look for a surface and there it is. Okay, so we're flipped now. So we're going to be able to apply this on our surface instead of letting it float in midair in a moment here. But that did it, that flipped it. So now all we have to do, it's kind of like, sounds trivial, but it's not that bad actually when you think of what we're doing. What we're going to do now is we're going to take the coordinates and simply when we create the node, we're going to give it the plane to this function right here so we can actually use the data, right? So I'm going to go to this function right here, create a turf, and I'm going to give it all of the stuff that we need right now, which is, I'll show you what we're doing. I'll just replace it. Okay. So we're going to give it the plane anchor. You notice the difference right here, center.x, center.y, and center.z. And that gives it the position of the node. And let's see. And the other thing that we're doing is we're telling it to be double-sided, and you'll see why in a moment. That way you can see the surface from above as well as from below. And I need to change this back to wood. And the geometry, I skipped over this. This is just as important, most importantly. We want to have the width and the height set to match the plane that it detected, right? Did you have a question? Okay. So when we create the node now, we're going to have a geometry applied, width and height, and then we're going to set the X, Y, and Z. So all those two things, that's the only difference between what we had before, right? Because before we just brought the image in and we rotated it. now we're actually going to tell, we tell the node where to be, where to create, where to be created. So now what I have to do now is I have to go pass, have to go give this plain anchor, right? As AR plain. In fact, I'm just going to say plain anchor like this. So plain anchor, we have that. We're going to pass that as a parameter, and let's see what happens. Oops, there we go. Okay, let's see if we detect anything here. Ah, there we go. So it's positioning it on top of the desk, and then you see what happens. As I move around, you notice the update functions are being called, right? So service update right here is being called, but it's not doing anything. So it makes sense that this just sits there and just covers part of my desk, right? So cool. So now we have it positioned right on top of the desk, and we have it where we want to be, but now we need to start updating it. So what we're going to do is we're going to do a couple things. I want to do, because updating a node in this case means removing the previous node and then adding the new node. And so what we're going to do is we're going to iterate through the nodes, all of them, and just delete them, and then just add the node based on the new plain anchor that we got in did update. So this doesn't change. We're going to leave this alone. And I'm going to do is I'm going to go iterate through the code right here. So first thing, let's grab the enumerate the nodes, just so you can see what that looks like right here. So this will just remove it, right? So we're going to enumerate the child nodes, and then we're just going to remove from the parent node all the children. And then once that's done, then we just go and add, just add it again, I guess, right? Same as before, looks like. Yep, just like that. So I can just grab this up here, and let's go ahead and add it back in. It's sort of repetitive, but this should work. And we'll have to also do this in the next function too, to remove the nodes if something needs to be removed as well. So we need to back up a little bit here, and let's go ahead and identify surface. Okay, so it made it bigger. You notice that? So Jamie, it looks like it's actually stretching that single image.
Yeah.
Yep. And as I pan to the left, it's going to discover more about my desk, right? Because my desk extends further here. It's hard to see because it's glass. It's got stuff on it. But notice what just happened right here.
Yeah, now it's covering the whole thing.
Yeah.
Wow.
It's covering the whole thing. And it's kind of, I've got a wooden floor, so it's kind of funny. If I try to go over here, it's gonna cut my wood floor with more wood. All right. And it maintained this node as well. So that worked out pretty cool. Okay. Let's take a look at what we're doing so far. So we're detecting the surface, we add the node, and then when we update, we simply delete all the nodes and then just add new nodes. And in the case of the did remove node, what I want to do is I want to grab here. Oh, all we're doing is we're actually just removing all the nodes, but we're not doing anything else, right? So let's do that in here. Okay. I didn't notice anything being removed. Let me take a look here at our console log. New service. Oh, there we go. Surface. Okay, it got fired. It got triggered there. A lot of updates, and oops, I skipped through that one a little too fast. New surface detected. Okay. All right, so it did it once, which is not really that often. I don't know that we'll notice it, but it's good. It's good to have it know that it's working. Amir, are you following along in code right now? Are you able to run this?
Yes, no problem.
Okay.
Giving it a try also. Yes.
Good. Yeah. If you, I think the code in the gist doesn't include the plain anchor parameter. So if you want, I can copy paste this into the comments or.
Yeah. Oh, yeah, you're right.
Okay. But anyway, yeah. So there it is. It's working, and then it's updating as it goes. So. It's actually looks like it did two different surfaces. I can see this because you notice how there's two. Oh, there we go. So it did delete it, and it created one large plane, which is really cool. That it did that. So this is why you want it to be able to delete and update and remove nodes, because it realized, ARKit realized, oh, you know what, I made a mistake. These are not two different surfaces. This is the same surface. So that was cool to see that. That was very cool. All right, I'm going to go ahead.
Could you please scroll up on your screen, on the coding screen?
Oh, sure. Right there?
Yeah, because I think I miss a thing. Please, some more.
Of course.
Yes. Oh, you didn't type anything. You did add turn node to the scene.
So the node is being added down here in the renderer. So let me see. It should be only added. Yeah. So the add node is added right here under did add, and it's also being done in did update.
Okay. It did add. I did that. It's okay. And then one more and did update. Okay.
Cool. You got it?
Yeah, I got it, but I can't see the wood texture on my table.
Oh, you're not seeing it? Are you seeing the in the console? Are you seeing the print messages in the console?
Yes. So, yeah, it looks.
Okay, let's go. Yeah, you should have. Okay, so in your viewed load, do you have the delegates? You might be missing the AR scene view delegates.
Yes, I tapped it.
Okay, great. And then you have okay, scene view delegate self, plane detection horizontal, and then you add then you basically start running, right? Scene view session run configuration.
Yes.
Okay. And that should be it. So if your renderers are firing as seen in the console, you're calling this function right here, create turf, as when it's assigning it to this variable, create turf, and that will then run this, which returns the node.
Yes.
So that should be it.
Did you pick up the wood asset and add it to the assets folder?
Oh my God.
Jamie,
I haven't changed it to wood. It's still grass. Okay.
there you go.
Okay.
Okay.
Okay. It's done.
Nice.
Let me rebuild.
Good catch, Jamie.
Okay. So, yes.
Yeah, that's great. So good. Yeah. Well, while you're doing that, I want to change this to vertical, and I want to see now if I can go ahead and vertical, and I want to see if I can now change this where I'm going to play with my walls instead of the floor. So I'm gonna remove this because I don't think I need to turn it now 90 degrees. And
So Chris, does that mean when you first create a plane, by default, it's on a vertical angle rather than a horizontal angle? Just that's the default? Is that why you had to turn it?
it seems that way, doesn't it? Yeah. Yeah, it did do that. When I brought an image in, it actually did have it on the same plane as the device itself, the way I'm holding the device.
Oh, okay, that makes sense.
Yeah, because if I start, yeah, so if I started when I start the running, I'm holding it like this, as you can see, I'm holding it vertically. And so it places the surface like that. But if I start like this, it'll apply the surface like, down below. So let's see what happens in this case. I actually took out the flip and I told it to detect vertical planes. So, oh, this is weird. It's detecting planes, but they're
not in the right orientation.
They're not in the right orientation, huh?
Huh.
Okay. So do I always need this?
So, yeah, I wonder.
Let's find out. That was weird. Okay, let's see what happens now. All right.
There you go.
There we go. So it's covering my wall. Cool. And it's making it bigger. Come on. It's a bigger wall than that.
I think the windows are constraining you.
Oh, you're right. It's not going past the windows. Huh. And then it's creating a bunch of other surfaces as well. Let me see what happened there.
Yeah.
Oh, that's really weird. So it's getting updated and stuff's getting, new surfaces are being detected, and I got a lot going on here. But yeah, the windows are messing with it somehow.
I wonder if it would detect your screen as being a plane.
Oh,
screen.
Good question. Yeah. Yep. Covered it up. I like this. This is great. I can't wait to have this as VR goggles, and I'll just mess with people when they're driving down.
Anything you don't like, you can.
Right. You can just exactly something. Nope, this is not good for your eyes. Block it off. Very cool. So it does work on the vertical, and I like how I did that with my monitor. That's really cool. Oops. Yep. Right away. Boom. There it is. It's covered it up. Okay. Wow. Crazy. Now, can we detect both vertical and horizontal? So this is, for you folks that are joined that haven't been with us before, a lot of this is unscripted. Some of it is, some of it so when we get to the point where we have the code working, we'd like to see if we can break things. So let's see what happens if we do both horizontal and vertical. Right?
That'd be interesting.
Yeah.
Science begins with experiment.
That's right. That's right. Okay, so let's see. Okay, so cool. It's detecting my desk and it's starting to cover it up. I'm happy with that. Let's go ahead and see what happens with my screen.
You know what, Chris? I think that's a single variable and it either gets to be vertical or horizontal. And because you've assigned
it, you're right. It is.
It's horizontal.
It's not an array. So I just overrode it, yeah. Let me see if there's a way to make this an array. Probably not. I doubt it. I doubt it. Yeah. So let's see. Dang it. So it sounds like we're limited. Of course, it doesn't mean. Let me think if we could do something else. If we could, I guess we could shut down this and then reinitialize after we detect some vertical planes. We could turn off. We could stop, right? We could stop running. We could store this somewhere in an array, what we already found, and then restart it. There's probably a way to do that. Yeah, I think that's going to take a little more work. Cool. So yeah, did that work for you after you got the wood in there, Amir? Cool.
Yes, I get it. No problem.
Okay, great. Let's try some other surfaces. I'm just kind of curious because I think I want to try like a very high, like a very large image. Let me see what happens with that. I'm going to try something like ocean, and I'm going to try an image that should have a lot of something high, yeah, like this. Let's see what happens here. Okay, it's on the desktop. I'm going to bring it in. And let's grab that from here. Okay. And we'll just go and change it in the view controller. Yeah, because that stuff gets stretched. If you're replacing an image, as it gets stretched, it's going to look. And I think, am I still? What am I looking at here? We're doing vertical. Okay, so let's go to the wall. There we go. Oh, this is cool though, actually. Oh, dang.
That upside down?
Yeah, it's upside down. So, oh, yeah, it's interesting that it's upside down. So it must have been the way we rotated it, the image, right?
Be careful, Chris.
What? Why? I know.
Don't wave.
Oh, this is actually really nice. So let's see. We want to rotate that. So do you rotate negative 90 degrees? Let's check that out here. Because that should be it, right?
Yeah.
You would. Okay. There we go. Yeah.
Oh, nice.
Very nice. I like this. So this is cool because one of the things that we want to learn to do is we want to learn how to use ARKit to create like an immersive like learning experience or an immersive classroom experience. And in this case, being able to like go to a wall, right, and just demonstrate or show, like pull up a whiteboard of an image would be really cool for people that are doing like a remote AR session, right? So I want to be able to do this, apply this on a wall, and then go up on here and go and say, okay, well, here's this image, or here's what this is. It's like as you're viewing this scene, it's dynamically replacing it with something else that you want to actually show people. So, okay, it's supplying a lot of, there we go, it fixed it. You notice that it was like showing a different image, and it seems to have figured it out, so it fixed it. And my lamp got replaced too. These are the different textures that are on my lamp right here. It's got a couple of, here, I'll stop running and see what it looks like. Let me go ahead and turn it on again. So that's my lamp, which is getting replaced. It's getting the surfaces applied. So, okay. All right. Okay, so yeah, but this was fun. We got a lot done. I mean, we have it where we actually, that was the goal really, to be able to post, replace a surface, put something up on the wall, and then see what we can do with that. So we're at that point where we've done enough for the day, right? And then we'll do a video. Yeah, that'll be the next time. We'll do a video and show that up on the screen, up on my wall. I can make my wall to the, we can do it on the outside of the garage or something and make the biggest screen for watching movies. Cool.
I'd like to request at some point that we be able to use touch gestures and select something. And I guess we kind of did that with the solar system, didn't we?
Yeah, we did that, but I think we definitely will need to go back and play with that, because there was so much more that we can do. We were touching the planets and making like reverse, like their orbits, but we still have to learn quite a lot about hit testing and like knowing. One of the challenges that we're going to have to overcome is knowing when one of the objects in our scene is hitting a wall or something. Now that we can detect surfaces, I want to be able to like put an object in space, and if you hit something when you're moving it around or it hits the wall, it'd be great to have it kind of show, like maybe bounce or do something. Right? Yeah.
Cool.
Yeah. All right. Any questions or other requests for next time?
I think this is great. I really appreciate it, Chris.
Yeah, my pleasure. Yeah, this is fun. Thanks for putting up with me as I crash things. That's kind of like what we do. We seem to do every time.
Yeah. I always learn a lot from watching things fail.
Yeah, exactly.
Hey, Chris. My name is Israel. I'm new on here, but I just have a quick request. I was wondering, I read on the comments, it says you would go ahead and post this session on the Meetup group. Is that right? Or is there another platform that you go ahead to post these sessions?
Yeah, so I hope I think I did start recording it.
Yeah, you did.
Okay, good. In that case, yeah, what I'm doing is I'll convert it to, I'll do some edits and things like this to cut out some of the stuff when we started out. And then I'll post it it'll go on YouTube, and I'll post the link on, in one of the comments on the meetup today.
Okay, awesome. Really appreciate your work. Awesome work.
Absolutely. Oh, thank you. Yeah, no, I appreciate it. So yeah, if you want to check on I think I should be able to get this done today. Later on today, I'll post it on the. I'll post it on. If not, check next week. Just go online and check it. Check the comments on the meetup.
All right, sounds good. Thank you very much.
My pleasure. All right. Well, thank you, everybody. This was fun, and thanks for joining us.
We'll see you in 2 weeks.
Okay. See you in 2 weeks.
Cool.
See you guys. Bye.
Bye-bye.